Okay, so there is no time to waste in calculus. So today we're going to go over the product and the quotient rule. They're just two rules for finding derivatives. You probably noticed that like a lot of the things we've been working with so far with taking derivatives have been like y equals 2x cubed plus 3 minus sine of x. But we have not been able to do anything that with these multiplied together, like a quotient or a product. Quotient would be division, product would be multiplication. So we are actually going to be multiplying two things. This is the first thing that's multiplied, right? This is the second that's being multiplied. Now for the sake of argument, let's imagine we couldn't distribute, okay? So get that out of your mind, don't distribute, because I'm just trying to show you the rule with an easy example. So the rule is basically this. The rule is pretty simple. It's kind of like if you had two things. Let's call them U. Oops, we don't need that. We don't need that. Let's call them U and V just for simplicity. The first thing is times by the second thing, right? And we have y equals that. We want to know y prime. Well, I'm going to use words here, and I'm going to say what's happening. I'm going to take the derivative of the first, which would be u prime, the derivative of the first. Take u, and that's a u prime, not a tick mark or an exponent of 1, times the second, and then plus the derivative of the second, v prime, times the first. So that's basically the product rule in a nutshell. You're taking the derivative of the first times the second, plus the derivative of the second times the first. So what's the derivative of the first here? Well, the first thing being multiplied here, it's x squared times all this, right? The first thing is 2x. The first thing is x squared, but the derivative of the first, u prime, the derivative of the first is 2x. Now you're going to leave the second thing alone. So derivative of the first times the second, plus derivative of the second. If this was the problem, just this x minus 4, your derivative of that would be 1 minus 0, or 1 plus 0, right? Just 1. So the derivative of the second is 1 times the first left alone. So you're noticing you're doing the derivative, leaving it alone, doing the derivative, leaving it alone. So don't forget about that. So it's the derivative of the first times the second, plus derivative of the second times the first, and that is f prime of x for this function that we're looking at. Alright, we're going to need to do a few examples, obviously. So let's keep this in sight and then try to figure out this next example. Whoops. Here we go. Perfect. Alright, so the next one. Oh, here's the actual spelled out version. So this is with function notation. So we have the first thing, and it's the derivative of the first times the second thing, which I guess is here. And then it's the derivative of the second thing, right? The derivative of the second thing times the first. So that's kind of like official way of doing it. Proof, not via video, so we're not going to do proof now. You lucked out. Okay. Let's keep looking here. Let's try another example. So, if we think about what the last page said, I just went ahead and copied from the last page, this rule here. This is a simple way of looking at it with easy notation, but it's not very rigorous, so that's why calculus books would never put this. But they're totally fine. This is the first, and this is the second. So we have to identify them. So we have to do the derivative of the first. So y prime, or dy dx, let's say, is going to be the derivative of the first, which the derivative of the first is actually two different things. It's 3 minus 4x. That's the derivative of the first. 3 minus 4x here. Now we got to multiply that by the second, left alone. Then we got to do the derivative of the second, which is actually just going to be 4, because we did all that. This is 0 and this is 4, times the first left alone, which is 3x minus 2x squared. The point is not to get this simplified. This is fine. Yeah, the back of the book will simplify this, but that's not our goal. We're not really looking for that, so this is fine. We did the derivative of the first times the second plus derivative of the second times the first. Parentheses are going to be really big here. You're going to want to use those. This is just a rule for finding the derivative whenever you see a product. Another one. Derivative of the first, which is going to be 1, times the second, which is going to be e to the x, plus derivative of the second, which, oops, I got ahead of myself, no, is e to the x, times the first. That is going to be your y prime. And because we can, we will make it look a little nicer, e to the x plus x e to the x. These are called transcendentals, by the way, and these are called algebraic. You're always going to put your algebraic in front of your transcendentals. Transcendentals are functions that you probably hate, e to the x, ln of x, cosine of x, those kind of things. And polynomials are the easier ones, the ones that you're more used to and you like better. They go in front. So this is actually a done out example as well. Feel free to pause, rewind if needed, but this should be pretty good. Let's keep looking. So the quotient rule. If you look at this for a couple seconds here, let's use purple and green this time because we're going to do a different color coding scheme. This is the top and this is the bottom. And I'll just put bot. So you're doing the derivative of the top, right? The derivative of the top, oops, that's the wrong color, times the bottom as is, the bottom as is, minus the derivative of the bottom times the top as is, and again, wrong color, times the top as is, all over the whole bottom squared. Let's identify. We've got the top, so when we're doing y prime, we want to have the derivative of the top, and the derivative of the top is simply 5. And that has to be multiplied by the bottom as is. You see in the formula there's no prime there, so it's just the bottom as is, which was x squared plus 1. That is your bottom, of course. Minus the derivative of the bottom, which is actually 2x. Because the derivative of the bottom is just 2x. Times the top as is, so that's going to be squishy, but we'll try it. 5x minus 2 all over the bottom squared. So we can just write it out, x squared plus 1 all squared. We're not all about simplifying, but if you want to get that to a polynomial, great. But it's not our goal. We don't really care. We just want to do the calculus. So the calculus is done as long as you don't have a fraction in a fraction, like so, right? That would be bad. Or a negative exponent. This is just off to the side for a second. These things are no good, but this is actually okay. You can do it out if you want, but you don't have to. So quotient rule works like that. So remember words, derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. We're going to say it many a time. Cool thing is that this helps us to understand the derivatives of a function like tangent. Because the good news is tangent is actually equal to sine over cosine. And now it's actually going to work with the quotient rule. Thing is, when we look at this right here, this is saying take the derivative of. The derivative of with respect to x, we're going to be doing the derivative with something that has an x in it. We can only do our rules with something that has an x in it, right? So derivative, manipulate the x of this. So this is really what we want to do, the derivative with respect to x of this. So we're going to actually do that, and that will just simply come out to the following. So I think it was purple on top and green on bottom. And I'm just going to say it. Hopefully you have it in your notes. the derivative of the top, which is cosine of x, times the bottom, which is cosine of x, minus the derivative of the bottom. The derivative of the bottom is negative sine of x. So I'm going to put plus sine of x because I can, right? Because I have a negative negative, times the top left alone, derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared, which is going to be cosine squared of x. This is the bottom all squared as one expression. Cosine of x squared. That's what this is right here. You have cosine squared plus sine squared on the top, you'll notice. So you have cosine squared of x plus sine squared of x. It should just be setting off in your head that it's 1. The top is 1. So the top is 1, the bottom is cosine squared of x. Therefore, this is 1 over cosine, so the whole answer here is secant squared of x, because it's 1 over cosine, so it's secant. That's the whole answer. That's the derivative of tangent, is secant squared of x. I'd like you to try, before you go on to any assignments here, just try to find the derivative of, I can't remember which one's easier, but why don't you try to find the derivative of, take the derivative of cosecant of x. Change it into a quotient, right? A fraction, and then do the quotient rule. Give it a shot. Okay, that's all there really is for today, so do your homework, and we didn't miss a day of class. That's a great thing. So I'll see you guys soon.